Hello, and welcome to the beginning of Unit 3. We're going to start off this next unit with a case study today. So we're going to have a little bit of background information, and as we work through this, you're going to be looking at some data and kind of trying to draw some conclusions and answer some questions as we figure out what is going on in the Gulf of Mexico's dead zone. So it starts off with a little bit of a story to give us a little bit of context here about summer at the seafood shack. Susan had moved in with Aunt Janet in Louisiana for the summer. She wanted to enjoy the sun and the beach and save some money for college next fall. A week ago, she found a job as a waitress at Captain Joe's seafood shack. At lunch, a businessman asked, "Where's the shrimp from anyway?" She'd been asked this twice before, so she knew the answer. From Thailand. The next morning, Susan and Aunt Janet were eating breakfast and watching boats on the Gulf. Aunt Janet pointed. "See that boat with funny stuff sticking out the back? That's George. He's a shrimper." "A shrimper? Then why does Captain Joe buy shrimp from Thailand?" "I don't know. Why don't you ask him?" Captain Joe was busily setting up lunchtime plates when Susan found him. "If there are shrimp in the Gulf, why do you buy shrimp from Thailand, Captain Joe?" He stared at her, annoyed by the interruption. "Too expensive," he grunted. At Aunt Janet's that evening, Susan found her aunt sitting on the front porch talking to George. After introducing herself, Susan asked him, "Is Captain Joe's the only restaurant around here that doesn't serve local shrimp?" "Definitely not," George said in reply to Susan's question. "Most of the area right off the coast here isn't good for fishing or shrimping anymore. Restaurant owners can get cheaper shrimp from farms in Asia or South America," he added. So here's the first time you get to take a break and do some thinking. What do you think might be the reason why shrimp have disappeared from local waters? You're going to try and generate a few potential hypotheses, and you're just kind of brainstorming right now, so see what you can come up with. George continued, "People around here have a lot of different ideas about why shrimp are going away. Some think hurricanes like Katrina are to blame. Others think overfishing, pollution, or climate change are the cause. I don't know for sure, but something has definitely happened. People are calling our part of the Gulf a dead zone, and it seems to be growing every year." So far we have four kind of working hypotheses for why this dead zone exists. They mentioned Hurricane Katrina, pollution, climate change, and overfishing. You may have thought of some others. These aren't the only four, but these are the ones that we're going to kind of investigate in this particular case study. So we're going to look at some data as we go through here, and this graph shows the annual changes of CPUE, that stands for catch per unit effort, for brown shrimp in the areas of the Gulf of Mexico. The colored bars, you can see this blue line, green, yellow, and orange, are decadal means. That's the average for a span of 10 years. So as you look at this graph, think about those four hypotheses. There's one of them that is not supported by this graph. So hopefully, as you thought about this, the theory that Hurricane Katrina is responsible for this is not really supported by this graph. A hurricane is one significant event. And so if it was due to a hurricane, you would expect to see a sharp decline at one specific point, but we don't. We see kind of a gradual decline over several decades. So we can kind of rule out the Hurricane Katrina hypothesis. So watching the local news that night, Susan saw an image of the Gulf Coast at the mouth of the Mississippi River that caught her attention. So take a minute and look at this picture. What do you notice? Based on the observations you made of this image, identify which of these four hypotheses is supported by the evidence in this image. Hopefully, when you looked at this, you noticed that even though the coastline is kind of back here, we have all of this kind of brownish stuff that's coming into the ocean. There's all of this sediment being washed in. And so this picture kind of supports the idea that at least part of this could be due to pollution. So over her original hypothesis, Susan decided the evidence suggests she should explore the pollution hypothesis. So she's going to do a little research and look into this some more. Susan decided to investigate the sediment plume to see if there was a link to the disappearing shrimp in the dead zone. Her research revealed the following map. This shows the watershed of the Mississippi River Basin. And if you're not familiar with what a watershed is, this is all of the area of land where the water will eventually run into these rivers and will eventually drain into the Mississippi and run out in the Gulf of Mexico. Susan realized that runoff from an enormous area could be causing the sediment plume, but the size of the Mississippi River watershed probably hasn't changed in thousands of years, and people have been shrimping and fishing in the Gulf for over 100 years. So what could be causing the problem now? Here's some more data she found. This graph is showing the average annual nitrate concentrations in selected rivers during 1905 to 1907, that's the yellow bars, and 1980 to 1996, that's the blue bars. Describe the pattern that you see here and draw some conclusions based on what you see in this graph. Here's another one that she found. This shows the annual nitrate flux. So the amount of nitrate is the bar graph here. And the mean annual stream flow, so that's kind of the amount of water flowing from the Mississippi River to the Gulf of Mexico. That's the line. So draw another conclusion here, describe the patterns, and draw another conclusion based on this one. So if we put these two figures together, what of these options down at the bottom do these figures tell you about the runoff of the Mississippi River Basin over time? Susan also recalled a figure from her biology course, of course. You may have seen something like this before. So this graph shows annual nitrogen inputs to the Mississippi Basin from major sources. So if we go back to this diagram, you can see that this is showing how nitrogen moves through the environment. This is a diagram of the nitrogen cycle and kind of shows where it can go and different things that affect the flow of nitrogen in an environment. And so here we have a graph that shows the different things that are adding nitrogen to the Mississippi River Basin. So you can take a minute and look at those different sources and the amount of nitrogen that has been put in from each of them over the 50 years between 1950 and about 2000. So based on that, identify the most likely source of nitrogen in runoff water that gets into the Mississippi River. So Susan realized her internet research had distracted her from her original question about shrimp. How could increased nitrates be connected to decreased fish and shrimp populations? She had figured out this much, and hopefully you came to these same conclusions looking at that data. Nitrates flow into the Gulf of Mexico from the Mississippi River watershed, especially the states further north. The nitrates are carried by the freshwater river into the saltwater Gulf of Mexico. So here's a little more information about the Mississippi River Basin. It's the largest basin in North America and 3rd million in the world. And it's a very productive farming region, which you should know, seeing as it covers a good chunk of Minnesota, the Dakotas, Iowa, Nebraska, all of that farmland. So when the freshwater river flows into the saltwater Gulf, what do you think will happen? Because all of these nitrates from that middle part of the country flow down into the Gulf, and the fresh water of the river goes into the salt water of the Gulf of Mexico, which is part of the ocean. So we are going to exit this little PowerPoint for a minute and watch a couple of quick videos that will show you a little bit about how this works. These are just a couple short demonstrations.
Here we have 2 glasses of water. The one on the left is very hot, and the one on the...
Just kidding. I guess we can see those right here. I'm going to try one other thing because I know I have these saved somewhere as well. Let me see if I can find these for you. Here, let's see if this one will work here. Oh, may not work. Sorry, should have tried this before I started. Nope. All right, we are going to come back here. And there's one other thing here that will work. So first of all, what these videos basically show is that when cooler water flows in, mixes with warm water, as you can imagine, the warmer water stays on the top and the cooler water stays on the bottom. Most of you know that warm air and warm water will rise. You probably also know salinity refers to saltiness. You probably also know that salt water is more dense than fresh water. So the salt water of the Gulf stays below the fresh water of the river. The Gulf also tends to be a little colder, and so it stays on the bottom for that reason as well. So there are a couple of different factors that kind of keep the Gulf water towards the bottom and the river water towards the top. And here's another little animation that will work, that will show you a little bit more of what's happening here. And it's got some little watery sound effects. So fresh water from the Mississippi River floats on top of the salty, dense water of the Gulf, inhibiting oxygen in the atmosphere from dissolving into the salt water below. So the oxygen mixes in from the atmosphere, but because of this separation, it doesn't get down to those bottom layers of the Gulf very well. Nitrogen and phosphorus also come into this top layer from fertilizer. And because of all those extra nutrients, it causes a lot of algae to grow. That's called an algal bloom. When those algae die, they sink down into the saltier water and decompose. The process of decomposition actually uses up quite a bit of oxygen. And so since more oxygen can't mix in very easily from the surface, and that decomposition uses up the oxygen in the bottom, a lot of the living things in that lower area either leave or die if they can't move. So that animation helps to explain a little bit of what we see happening in this area of the Gulf of Mexico. So this summarizes that same thing. Oops, I just got to close this so we don't have to listen to that. There we go. The excess nitrogen and sunlight in the surface water leads to algae blooms, which provides food for zooplankton like copepods. Those are little microscopic creatures. But those wastes and the algae, when they die, sink to the bottom, and decomposition uses up oxygen. So what ends up happening with this interaction of fresh water and salt water and warm water and cold water and the fertilizer that's added into that top layer from the runoff with the extra nitrogen is this process called eutrophication. Eutrophication leads to hypoxia in the benthic waters of the Gulf. That's a really sciencey way to explain what's happening in the Gulf of Mexico. So what I'd like you to do is rewrite that sentence using less sciencey words so that other people who aren't taking this class could understand it. You might need to look up the words eutrophication or hypoxia or benthic. So do a little research if you need to and rewrite this sentence in a way that makes a little more sense to a non-science person. This diagram just summarizes this one more time. Here we have another figure that presents evidence that hypoxia is actually occurring in the Gulf of Mexico. So study this for a minute and explain what you see here. And here you can see the area that in midsummer had hypoxia, had those really low oxygen levels towards the bottom of the water. And you can see that the average, here's kind of the long-term average, but the average in the most recent 5 years of this data is quite a bit higher. So this is an issue that is increasing and becoming more and more of a problem in the Gulf of Mexico. So this is one important thing to realize. We've been talking so far about pollution as the cause of this, but does this mean that climate change and overfishing are not part of the problem as well? Hopefully you said no. The evidence supports the fact that pollution is at least part of this problem, but we haven't even looked at whether climate change or overfishing might also be contributing to it. And we're not going to look specifically at those factors in this case study, but it is important to realize that just because we find evidence to support one hypothesis doesn't mean that that's the entire cause. So back to our story. Upon figuring this all out, Susan was quite upset. She was amazed that farmers in the Midwest might be to blame for the lack of shrimp in the water off the Louisiana coast. As we wrap this up, I want you to think a little bit. Suppose that you are on a government panel studying the dead zone problem. What recommendations would you make for solving the problem of the dead zone? Who should be responsible, and what actions should they take? Just so you're aware, this isn't a problem that is unique to the Gulf of Mexico. Eutrophication, that process of added nutrients leading to algal blooms, which then lead to depleted oxygen levels, are happening around the world. And this map kind of summarizes some of the major sites where this is happening. So you can see this is a pretty widespread problem. And it's a problem that is related to the idea of nutrient cycles. Particularly here, the nitrogen runoff is what we focused on primarily. And for the first part of this unit, we are going to be looking at nutrient cycles and reviewing those a little bit, and looking at how they interact with ecosystems and how humans, again, can interact with these ecosystems and change these nutrient cycles and alter the cycling of nutrients. So this kind of continues some of the ideas from the beginning of the last unit, but is also going to lead us into thinking about what some of these nutrients are used for and a little bit of biochemistry. So that's where we'll be going over the next few days. There will be some follow-up questions that you'll need to answer based on this case study. So remember some of the things that you saw in here, and you can always come back and watch this video again if you forget some of the details. Have a great day. We'll see you tomorrow.